The broadcast webinar has not started yet. Can I get your feedback, guys? Do you see the presentation as one slide or two? Our weekly webinars on everything hazardous areas and pertaining standards, such as IP ratings. This week is on IP ratings. What does IP66, 67, 68 all mean? Your presenter, my name is Michael Merrington. I'm working for IndEx as General Manager. We are hazardous area quality and compliance experts. I'd like to welcome everybody. So let's jump into our presentation. So where and why the need for IP, ingress protection? So we're talking about protection from dusts and waters. Examples in everyday life includes our phones, within our bathrooms and washrooms, light switches, lights, outlets, GPOs, whatever someone may call them. Where did this need originate? Well, protection of people within their own homes. This standard came out in 1989, the one that will be in the next slide, which identified the required IP ratings around sources of water, water basins within bathrooms, washrooms, because people were getting injured, electrocuted, killed due to use of electrical equipment or touching of, let's say, a light, an outlet, or a light switch. So this was brought in to increase electrical safety. So personnel protection, ingress protection. Now, how to achieve this protection of people and equipment? Well, standardization took place. So IP ratings were defined by EN or IEC 60529 as of 1989. What it defines is levels of sealing effectiveness of electrical enclosures against intrusions from solids and water. Now we should also say moisture. And now examples of IP8 tested and certified devices, we would be looking at our iPhones, our Samsungs. Now, a quick visual indication of what these mean, if we had a light, all the IP ratings for solids and water. This presentation, we will not touch on solids very much. This is primarily about water. 0, no protection. 1 and 2 is basically drip proof. 3 and 4 is rain. 5 and 6 is jets of water, while 7 and 8 are immersion, submersion, while 9 is very high temperature and very high pressure. Next slide. So under IEC 60529, these numbers are covered in their chart. What we just said there. The new inclusion was IP69, specifically the 9, high pressure, high temperature. Okay. Now we're going to do a poll right now. So, which IP rating is best? Now, take into account all specifications, standards, requirements that are requested. 44% have voted. Once we get up to about 70%, I will close the poll. Give it another 15 seconds. Okay. Thank you very much. I'll share the results. So 20% thought IP69. You'll learn further in this presentation why that may not be correct. Same for the next 4 answers. Now the fourth one down, 15% of you, that is a very good device that is rated for everything. But you have to take into account the manufacturer, the EPC, and the end user's requirements. A device that is rated for all 4 of those IP ratings would be a more expensive device. Perhaps it would be overkill. So there are the considerations of the customer, purchaser, end user, and manufacturer. Okay, next slide. All right. So when we talk about ingress protection, there are test conditions that must be met. Now, atmospheric conditions of the water is defined by another standard which is older, and IEC 60068-1. It recommends that the atmospheric condition is 15 to 25 Celsius. Also, the water temperature could be that. Also, the relative humidity in the room, as well as air pressure. Now, within our industry, we have certain questions, evidence that things do not stay at 15 to 35 Celsius on a project. Ambient temperatures can vary anywhere from -50 to +55, plus UV considerations. So black body equipment can get higher than 55 degrees. Then there's also temperature variation or temperature swing between day and night, or even within a few hours, where a piece of equipment can go from hot to cold or cold to hot in a short period of time, which then can draw in moisture into the enclosure. We also have to consider ourselves, what about seals and O-rings? And a big one, degradation, the asset's life cycle. If that equipment is meant to last 40 years, is IP testing doing this test? Another one would be elevation. Projects which are at high elevations are going to be outside of that relative air pressure. And then length of time of the test. So, another poll question. Is IP66 rated for IP22? So later in the presentation, we'll go over what the IP ratings cover. But this is a general knowledge. This is a way to anonymously give your answer. So it's a good indication of where everybody's at. Don't feel shy. About 74% have voted. Give it another 10 seconds. Okay. So 61% said yes, which is correct. IP66 is rated for IP22. Everything for the 6s and below is rated for all those numbers below it. Okay. Next slide. Now, example of testing. Not many people get to see what a test procedure, test setup looks like. So when we talk about a drip test, this is your IPX1, X2. X indicates that test is not being done or is not covered. So if a piece of equipment is rated IPX1, it has not been tested for dusts. So this one is a drip test. IP30 X3, X4 is a rain test. A oscillating nozzle that goes back and forth. While IPX5 and 6 are direct jets of water at a specified distance and a specified temperature. Now, whole question. Is IP67 rated for 66? Once again, don't be shy. In this presentation, you'll learn if your response is correct or not. It's okay. All anonymous. Another 10 seconds. Make sure you hang around to the end of the presentation because I will show you a chart from the standards which answers everything. Now, I know this is a contentious issue in the industry, but IP67 is not rated for 66. We'll go into why later. So 48% of you, please stay tuned. So when we talk about IPX7 and X8, we are talking about, in simplistic terms, these are tubs. The device is turned on and is immersed for up to 30 minutes for IPX7, between 15 centimeters and 1 meter, while IPX8, the time is dependent on the manufacturer's request and a depth of 1 meter or more by manufacturer's request, typically 3 meters. But once you start getting down to 10 meters, we start getting into the unit called atmospheres. Another poll question. Is IP68 rated for 67? I think this one's a much easier one for everybody. %, can give another 10 seconds. You guys are quite quick on this one and favorable response so far. Okay. So 70% got it right. 68 is rated for 67 because it is a more stringent test. We'll show you exactly where in the standards where this is clearly identified. Now, testing parameters. Table 3 within the standard says the brief description and the definition of what each test is. Now, 1 and 2 are dripping water. 3 and 4 are spraying water, more like raining. That oscillating, that turning metal tube that sprays out of it. While 5 and 6, the keywords are jets of water. 7, the important word is immersion, submersion, immersion, underwater. Those words all matter. Vertically, spraying, splashing, jets, jets, immersion, immersion. 9, high pressure and temperature water jets. okay? Test conditions are defined within the standards. Now, a little bit of harder question this time. Is IP69 rated for IP66 or 68? Give it another 5 seconds. Okay, 87% voted. Now, only 31% of you got this one correct. Hang around to the end of the presentation. There's an exact table that says why. But IP69 testing is nothing like 66 or 69. Think of the test parameters in the test conditions. If the temperature is not the same, how can it be considered rated for the other test? It's a matter of more common sense, I would say. But once you've actually seen the videos and some of these things. Okay, testing parameters. IP54 versus IP66. Now the IP54 test, which is rain splashing water, is a 10-minute test. But the IP66 test is a 3-minute only test. Now, who here actually believes it only rains for 3 minutes? Or 10 minutes? When it rains in certain locations like in Australia, offshore, Vancouver, New York, Chicago, wherever, it doesn't only rain for 3 minutes. And the pressure, the force of the rain, quite often does get up to about the force that an IP66, what that nozzle would be spraying at. Let me see if I can show you guys a video. Okay. In your handouts, you will find videos for you guys to watch. And also after the presentation, I will put them on our YouTube channel. So at this time, I think it'll be a little too difficult to play the videos and it doesn't have good quality when we play it over this. Next, IP66 versus 67, 68. Now remember, the 66 test is stream of water, basically jets, for 3 minutes. While the 67 test is immersion, temporary, for 15 centimeters to 1 meter for 30 minutes. Water temperature must not differ more than 5 Kelvin. Now, 68 is defined by the manufacturer, but shall be more severe than 67. And you shall take into account the conditions of the enclosure for continuous immersion in actual use. So 66, jets of water, 3 minutes. Pressure, driven pressure. When you look at 67, we're talking about only immersion. There is no jets of water. The only pressure is the standing water, while 68 is greater. This one is temporary, 67, while 8 would be continuous use as defined by the manufacturer. Could be 1 hour could be days. Now, real life examples. Let's talk about our phones. Many phones are rated for IP68, meaning it's rated for 67 and 68. If it has not been tested for the lower form of protection, so 6 covers 1 to 6, 8 covers 7 and 8, and 9 is only 9. So the Sony Xperia actually has been tested for jets of water. The iPhone, the Samsung, they have not. While the Caterpillar phone, they've tested the 68, 69, so it can handle pressure washers, jets of spray. But that does not mean it is okay in rain, because it's different testing conditions. And there is evidence in our industries that water will get in. As an example, if you had a stone and you dripped water on it for 1 week, it would start carving out the stone. If you spray it with a pressure washer for 5 minutes, you're not going to do anything to the stone. Different conditions cause different outcomes. So if you don't test for it, you can't prove it. It's not verified and it's not validated. Okay. What is IP69? Well, it's protection against high pressure, high temperature jets, usually for wash down or steam cleaning procedures. Example industries: offshore, pharmaceutical, vehicles, wash down areas. Now, within the industrial field, I would point out operators. Operators like to use hoses and blast everything. This is a consideration that is sometimes forgotten within our industry, but offshore, it's important to get the salt off the equipment. In mining, it's important to get certain chemicals, sludges off of the equipment. So the operator, he doesn't concern himself with IP ratings. So perhaps that's why more offshore users, more industrial users are starting to call for the IP69 rating of their equipment. Now, IP69 examples. We have motors. We use, let's say, pharmaceutical industries. We do not want dust getting in there. It can cause explosions. But you need to clean down that motor sufficiently. Pressure washers or steam cleaning is usually used. Cameras, gas detectors, proximity sensors, even lighting, even little junction boxes and terminal boxes. Now, pay attention to the Stahl piece of equipment here. It's rated IP66, 67, 8, and 9. It could have actually been rated 66, 68, 69, and it would have taken care of all considerations. But they went further and did further testing. As the manufacturer, they wanted to ensure that their product would be accepted by any end user, by any customer, as to not neuter themselves, to not restrict themselves in their sales of their equipment. Obviously, this camera would be a higher quality piece of equipment and would probably be more expensive because it's higher quality, higher safety. Now, what does the K stand for? Perhaps some of you have seen IP69K or 66K. This actually comes from a different standard, ISO 20653, road vehicles. As the vehicle drives down the road, water that's suspended in the air or raining, the speed of that vehicle increases the force, speed times mass. So the speed of the vehicle adds to the force of that water. So the K is for increased pressure. and increased requirements for dusts. Now, this standard says specifically IP codes are derived from 60529, except where K is called for, which describes the requirements for road vehicles. Now, why would the EEHA hazardous area industry use this standard? Marketing, obviously. Proof that their equipment is longer lasting, that it's gone under more stringent testing, it's safer. No water, no dust getting in, health and safety and environmental protections are even greater. It's a higher quality product. So you'll start finding some offshore users actually call for IP69K. Some manufacturers have skipped IP69 and gone to 69K. There is a difference between them. So what is the difference? Well, IP69 is measured by force, while IP69K is measured by pressure. I'll leave you to research that a little more, but specifically IP69K, the distance that the pressure washer, the nozzle, is up to 50 millimeters closer to the device. So it's a more stringent test. Now, there are problems with the standards. Between the English on the left and the French translation on the right, there is something missing from the IP69, the 9 test, within IEC 60529. In the French test, they clearly identified the temperature that the water must be at, 80 degrees plus or minus 5 Celsius. In the English version, it's not called for. Testing done by EXTLs, hazardous area testing laboratories, or non-EX testing laboratories, make the mistake of not having the correct temperature or just going with standard room temperature, because when they read the standard, it doesn't mention the temperature consideration. Now, an amendment may have come out or may come out, but this misunderstanding continues within our industry. So if it's not tested correctly, it could possibly fail, and there's potentials for source ignition if these fail. So, question. This is a multiple choice. There's more than one answer. What does the K stand for? I'll give you a hint. There is no incorrect answer. Sorry, number 2 should say we do not use K. Sorry about the English of that. Give it another 10 seconds. Once again, answer number 2 is we do not use K. Sorry about the mistake. Okay, we'll close it now. Now, there's multiple answers to this. The correct answers are 1, 3, 4, and 5. It is additional requirement on top of 60529, but it's found in ISO 20653. It's not used within 60529, and it is greater testing requirements. Okay. Next, we come into North America. When we start talking about NEMA, equipment manufacturer ratings, these are NEMA enclosures, they define it under these numberings, 1, 2, 3, 4x. It goes into greater detail than IP ratings. Now, the important thing about this is that NEMA ratings can be used within IP rated areas with a fitness for purpose assessment, but IP ratings can not be used where NEMA ratings are called for. You'll see in the next slide why, but this chart is not sanctioned by NEMA, IEC, it is only as a guideline. NEMA 4X, they say IP66. This is not always the case. Different testing, different temperatures, different pressures. Well, there's actually 2 standards within North America for NEMA ratings, let's call it that. Actually, they call it type ratings. That's the UL's designation under UL 50 and UL 508. Well, the NEMA standard is NEMA standard 250. As you can see, the NEMA has a greater body of requirements for testing, while the UL has less, and the IP has even less. So IP can't go into less requirements, but the NEMA ratings are tested for rain, sleet, snow, corrosion. They go under greater testing. Now, this one should be answered. I gave a few answers. Multiple choice. Can North American ratings, rated equipment, be used in IP areas? Wait till about 70% of people have voted. Another 10 seconds. Don't be shy, multiple answers. Okay, 80% voted, 82%. Now, the most correct answers are maybe. And which North American standard was used? It has been found within industry that IP or NEMA 4 or NEMA 4X is sometimes IP54 all the way up to IP66. If one were to immediately accept a NEMA or UL type, you could be putting the end user in significant danger. A transformer, high voltage motor, intrinsically safe equipment, SIS, safety instrument system equipment, could get water into it. That would destroy its EEHA protection technique, meaning not destroy, but would compromise. So really, the 2 answers are maybe with a fitness purpose assessment and which standard was used. Sometimes it's a yes, but you have to assess it. You have to do a risk assessment. Now, there's a slide after this one. I want to thank everybody for attending, but we have one more question. Hopefully with everything we've gone through, people can answer this multiple choice question. What are important considerations when choosing IP ratings? There are multiple answers to this. The first person that answered, by the way, whoever that was, you got it 100% correct. %. So we're going to wait till about 80% of people get this one. Don't be shy. There's many answers. Another 10 seconds. Okay. So, what are important considerations? All of them. Absolutely all of them. Now, IP markings, this is important for designers. Designers shall block the use of equipment that is not the correct IP rating as per their facilities end user specifications. If the manufacturer or the testing laboratory doesn't test to the correct IP rating or doesn't mark their own documentation correctly, an EPC, a purchaser, may not purchase their equipment. A manufacturer will be subjecting themselves to reduced sales by not marking or by not testing their equipment correctly. Another consideration is the testing laboratory may make a mistake, but the manufacturer expects the testing laboratory to always know what they're doing. I'll let you know, human error, human-induced faults are 99.9% of all faults. People make mistakes. Specific test characteristics of IP testing. I showed you with IP69. Under the English language of the standard, they forget to mention the temperature requirements. So how many test laboratories have made a mistake during their IP69 testing? I would probably make the estimation of all the EXTLs. I'm guessing that would be over 25%. You can't expect people to go down and read the French. Perhaps that could get up to 80%. Do we expect everybody to be an expert, or should we standardize things so that everybody can understand? That is the point of standardization. We all don't need to be an Einstein to get the point. So right now, the standards could be made better. Now, standard specifications and local regulations. Yes, different country standards, different countries' regulations may call for a higher IP rating than is specified by the end user. So their requirements may not meet their legal requirements. They can put themselves at legal risk by not applying, by not meeting those local regulations, those industry standards, international standards. Now, the specific area of use. Is it used inside? Is it used outside? Is it offshore? Is it near the ocean's edge? Is it in a climate like Kitimat, British Columbia, where it rains all the time hard? Is it where cyclones or hurricanes may be? Those would be key indicators that you would want multiple IP tests. Now, the industry type. Anywhere that uses a pressure washer or steam cleaning, such as pharmaceutical industry, you would figure they would call for an IP69 test on top of the 68, and perhaps even 68, on top of the 69, and perhaps on top of 68. Now, we have a question from somebody asking, is an IS device or simple apparatus require an IP rating? Will it be marked on the apparatus itself? So IP equipment is supposed to have a minimum of IP20. When we're talking about barriers, IP20, that would mean that it would be in another EX protection technique, within a building, or within an enclosure. We would not have that outside, obviously. Now, simple apparatus and things like that, yes, IP2X. While the simple apparatus, that would fall under what is the minimum IP requirements that the specification, usually by the EPC or end user, calls for. Usually IP54 minimum. Nearly all EX protection techniques are minimum IP54. EXP is IP44. EXE with insulation on terminals and other things is IP44. Yes. Now, the most important slide where you will find all your answers to IP ratings. Within the IEC standard, the words versatile and restricted are what you must apply to, okay? A device that is rated IPX5 or X7 is good for jets 5, so 1 to 5, while 7 is rated for IPX7 only. But if it was IPX6 and 8, it's good for 1 to 6 and 7 and 8. But equipment that is restricted, see here, IPX8, what is it rated for? Only for immersion. It's rated for 7 and 8. These restrictions are what identify that these cannot be used or assumed to be tested for the other IP requirements. Everything that you see in red, there was a red line of the standards. Everybody was confused, so they changed everything. Now, look at IPX9. It's restricted. It's only good for water jets, but only for 9. Because there's specific tests for 5 and 9 or 6 and 9. So water jets at 9 are only good for 9, but water jets at 6 and 9 are good for 1 to 6 and 9. This table within IEC 60529 is the definitive answer that would correct perhaps everybody's misunderstanding and answers to the previous questions. The words versatile and restricted are highly important. There's a delineation, a segregation between the numbers 6 and 7 and 8 and 9. 1 to 6, that's different set of testing. 7 and 8, different set of testing. 9, different set of testing. So 1 to 6, we're talking about rain and drips and water jets. 7 and 8 is immersion, submersion, while 9 is very high temperature, very high pressure. So IP69 is not rated for any of the 61 to 68s. IP67 or 68 is not rated for 61 to 66 at all. There are further lines within the standard below that explains the words restricted and versatile, but feel free to buy the standard, download the standard, and understand for yourself, and to review this presentation afterwards. It will be available on YouTube. Now, question period. If anybody has any questions, please ask. But we do have 73 attendees, so please forgive me if I can't get to everything. Now, category 1 and category 2 not explained. We will not go into that. We are mainly talking about these IP ratings, water ingress for the EEXX industry. Is third-party certificate required for EEXX equipment, or is manufacturer's declaration accepted? So you would be talking about ATEX only. Under ATEX, Zone 2 equipment can be a manufacturer's declaration. Now, there's still testing requirements that they must do. EMC, IP, things like that. When it comes into IECEx and other standards, it still must be third-party tested and certified. So by an EEXTL, tested in laboratory, and an EEXCB, certifying body. While under ATEX, it's called notifying body, and Zone 2 equipment is not as stringently tested or certified. It is a manufacturer's self-declaration. Mike, can you please clarify that 7 and 8 do not cover 1, 2, 3, 4, 5, 6, 7, 8? So we look here. IPX8 says it's restricted. Under the column for temporary or continuous immersion, it is rated 8. Under water jets, it has no rating. It is not rated for 1, 2, 3, 4, 5, or 6. IPX7, restricted. Immersion, it's good for 7, which means temporary immersion. Under water jets, 1, 2, 3, 4, 5, 6, it is not rated. Okay, ooh, a lot of questions. Hold up, guys. The exact phrase in the standard is 7 and 8 do not cover 5 and 6, but no mention of 4 and below. The reason that it doesn't mention that is because when you go to within the standards and cover IP66, it does tell you that 6 covers from 1 to 6, 5 covers from 1 to 5, 4 covers from 1 to 4. So they didn't go into too much detail. This is already confusing for people. They didn't want to make it more confusing. Will all EEXX certificates include the IP rating? I've seen some ATEX equipment that does not include the IP rating. Under the IEC standards, yes, they shall list the IP rating and shall have IP testing. If they don't, that's going to possibly cause the manufacturer to not be able to sell their equipment to certain end users, or procurement people will question their IP ratings. While they may produce a data sheet, if it's not on the certificate and it's not on the EEXX data plate, if one of those documents or physical devices, the data sheet, the data plate, and the brochure, if one of them is lacking that information, my own personal risk assessment, I would not accept it. There are errors within that manufacturer, or perhaps within that certification body or testing laboratory, and I would be apprehensive to accept that equipment. We have found within Australia, a certain manufacturer of LED lights has gone under, has gone out of business because they did not meet their IP66 rating, and now it's costing end users millions upon millions of dollars to change out all those lights. ATEX, once again, if you look under EN IEC 60079-0, general requirements, section 29.4, marking requirements of EEXX equipment. Is IP applicable for any enclosures such as valve actuators? A mechanical, if there is no electrical connections, the thing is that a manufacturer can still ask for IP testing. Now it's supposed to be for electrical components inside, but some people apply this standard to mechanical devices. Now, when we come into 80079, the mechanical standards, these IP ratings can be beneficial. So there's still confusion within the industry. Is this table from a standard? Yes. IEC 60529. The table you will find near the end. For electrical equipment to 60079-36, will they require the IP rating? I will double check that later, but I would make a safe bet and assume the more stringent requirement of requiring an IP rating. But I will get back to you on that. As per equipment minimum, IP54 is deemed enough, but they can still test to IP66, or is it a manufacturer requirement? Once again, IP54 is a 10-minute test, while IP66 is only a 1-minute test. The manufacturer can ask for greater testing, greater periods of time, greater pressure, greater temperature. Some manufacturers only tested their equipment for 3 minutes at IP66, and it has failed within Australia. Because when a cyclone comes through and 300-kilometer-an-hour driven water, it's gonna fail, which then negates the EEHA protection technique, water inside, arcing, sparking, potential source of ignition. Is IP54 enough? That is for the manufacturer and EPC to decide, and the end user. But if I were to have a facility, I would call, depending on the area, I would call minimum IP66, but in industry, usually we have instruments at IP65, electrical at 66, motors at 55, but rarely do we only accept IP54 outside. Now, glanding, that'll be next week's subject. That goes into that more. IP suffixes, M or S. We're not covering that this time. We're just talking about water. There's too much involved with IP ratings. We wanted to make this simplified. Sorry about that. Perhaps another time. Great webinar. This clarifies the myth in the industry that the higher number is better. Thank you very much. Thank you for that, the gentleman from India. The M is for motion and the S is for stationary, those suffixes. Yep, but we're not going to go into that. Too much information, not enough time. Does this relate to flammable gases? Well, flammable gases, if you had a potential source of release and you defined it a hazardous location, hazardous area, then you choose your selection of your equipment, your minimum IP ratings, minimums, according to the standards, IP54 for nearly everything, IP44 for EXP, IP20 for EXI, but would you only accept IP20 for intrinsically safe apparatus outside? Is IP54 enough? Even in dry locations, that dust 5 would not be enough in many instances. Dust will get inside. Is your facility to last 5 years, 10, 25, 40? Certain ones in Australia have 40-year design lives. Now, it may be more expensive, but once again, it's the end user has to take into account specification standards, local regulations, cost, quality, safety. They have to consider everything. I don't envy them, but the easy choice would be a higher IP rating, but from a reputable manufacturer, from a reputable testing laboratory and certification body. Not all are the same. Can you share the webinar slide for references? Yes, after this presentation, one day we will give you the link for our YouTube page, which lists every single video. Is there a minimum time for IPX8? Yes, so if we go back to the test parameters of 68, apologies, it shall be greater than IPX7. So X7 is a 30-minute test, so it can be anywhere from 31.1 minutes to days, weeks, perhaps years. I don't know who's going to do that long of a test, but it's possible. If a product fails an IP66 in EX testing, so it'd be IP testing, but let's say by an EXTL, whereas it passes an IEC 60529. Okay, so I think you may have made a bit of confusion. So an EXT, usually when you have a test laboratory test a piece of EX equipment, they'll do the IP testing and the EX testing because it makes more sense for one laboratory to do all tests than to ship the equipment multiple places. So a testing laboratory will invest in an IP testing those machines that you saw. But if it fails IP66, if that's only the 3-minute test, it's not very good. But do others test for longer periods of time? Yes. Yes, they do. The test involves 3 minutes of the light being on. Then they open it up and see if any water was drawn into it. But it's only 3 minutes on a new piece of equipment with brand new seals. Noted about the markings of IP for S&M. We rarely see them on our pieces of equipment. It's honestly on all the equipment that across all the projects that we've worked on, less than 1% of cases do you see the following letters of the IP ratings, after the second number. Rarely do we ever see the other. Somebody asked or said that flame proof and explosion proof are the same. No, they are not. Different testing requirements. One is based off of ENIEC 6079-1, while the other one is a UL 1203. So this is going outside of IP ratings, but they are not the same. To install a flame-proof enclosure into a classes and divisions location where explosion-proof equipment is highly dangerous. To install explosion-proof equipment into a classes and zones or zones, that requires a fitness for purpose assessment by the end user's responsible engineer, the responsible person, owner engineer. Or somebody else has to make the call. When an enclosure is rated IP67 and has a cutout made for a cable entry or for indicator installation, how to maintain the IP, how does the requirement vary if installed indoors or outdoors? Well, when there's no threads, that can only be guaranteed to be IP54 with an IP washer. If there are no threading and it's just an open hole, you shall always use an IP washer. Now, if it's inside or outside, if an enclosure is IP67 and it has a hole cut out, that's not IP67 anymore. it would seem to have been modified. For it to be IP67, the gland definitely has to have a threaded entry, specifically because of the immersion, okay? The videos that I will share, I will include that on our YouTube channel, and they will be identified as, we'll call it webinar 4, video attachment 1, 2, 3, 4, 5. So you'll be able to find all examples of these videos, but it won't be for each IP testing technique. It'll be for like 65, for X5, X6, 7, 8, and 9, the interesting ones. What does the canopy affect the IP rating? Will it improve it or not? So I think you're talking about sunshades or rain hoods. That does not improve the IP rating of the equipment. If the hood is not an essential part of the equipment, meaning if it's not tested with it, it cannot be confirmed as to affect the IP rating. Now, some equipment may have let's say a gas detector may have a deluge baffle, which goes over it. When you change it, it says within the certificate and the data sheets that if you use this, it tells you the changed IP rating. But independent sunshades, rain hoods, those do not reduce the requirement of an IP rating. It's just an extra add-on that the specifications end user calls for, which protects their equipment from UV and lessens the chance of water ingress, because not all IP66 devices are going to survive, you know, perhaps 4 minutes of rain, 4 minutes of jets of water. What is your YouTube channel name? It is EX Professionals. I'll share the link within our email to you. How to spot the enclosure breather is suitable for the IP rating of the enclosure. I often see boxes with condensation trapped inside. This will be for next week's presentation. Right now, we were talking about testing and manufacturing specifications. Next week, we'll talk about application, actual field examples. But to give you an idea, humidity, which is the gaseous form, vaporous form of water, hot air rises. You have a breather drain, when it's at the bottom of the device, it's really only operating as a drain. It is a very poor breather because that humidity is going to stay trapped inside and it's going to raise to the top of the box. And when the box cools down, that is going to condense into water. That water vapor is going to turn into a liquid. So why are you going to keep finding water inside your boxes? Because you don't have a breather near the top side of your box. Some enclosures, important ones like control panels, have 2 breather drains installed. When it's installed at the bottom, it makes a very good drain. When it's installed near the top, it makes for a very good breather. Why do our watches have water resistance up to XX meters instead of IP ratings? They do have IP ratings, but okay, so you're talking about atmospheres versus IP ratings. Some, let's say a smartwatch can go up to IP68. That could be any depth for any period of time, depending on the manufacturer. While IP67, the 7, up to 1 meter, minimum 15 centimeters, 30 minutes minimum, okay? Further than 10 meters, every 10 meters is an atmosphere. So it may say 2 ATM, 2 atmospheres, 20 meters, but it may also say IP ratings. Because like we said about IP ratings, IP68 does not mean you're rated for IP66. But if you're rated for IP68 and 2 atmospheres, hopefully you understand what I'm saying. Different testing techniques requirements require completely different testing. Any more questions? Or I think we'll give it another 10 seconds. If nobody has any more questions, we will end the webinar. There will be questions, surveys for you guys afterwards to get your input, feedback on this webinar, and perhaps your ideas for our next webinar. Want to thank you very much. I think we got up to about 80 people today, and I'm hoping that you gentlemen enjoyed this to remove the confusion within our industry. This IP66/67 continues to cause issues for engineers, designers, procurement, installers, inspectors, end users. We need to nip this in the bud. We need to educate in a much better method than currently has been happening within all industries. So I hope that we at IndEx can make a difference for you. Thank you very much.